Okay, this is working with section 6.1. We're going to go through a little bit of vocabulary just because this is some newer information. A relation is a pair of inputs with outputs, and it can be represented with ordered pairs or a mapping diagram. So we'll learn a little bit in this lesson what a mapping diagram is. A function, on the other hand, which is what this whole chapter is about, is a relationship that pairs each input with exactly one output. So a relation and a function, very similar. You're going to have inputs and outputs. With a function, you will always only have one input go exactly to one output. So a relation could have more than one output per input. So what does it mean with an input versus an output? An input is going to be your X values or the X's that you are using, and an output is going to be the Y values. You guys have worked with inputs and outputs, working in when you guys would substitute in for X and solve for Y and then graph those. You have worked with a function previously, it's just we haven't said that it was a function. We've said that it is a linear equation. So that's just some wording that we're going to be working with in this chapter. Okay, so we're going to go ahead and work through our activities. So this is in your practice journal book. I've gone ahead and snippet tooled out of the hardcover book. That's why mine's in color. So it says work with a partner, copy and complete the mapping diagram. So you guys don't have to copy it because it's in your practice journal. So you'll notice here we have, this is what is called a mapping diagram. You guys will be working with this quite a bit throughout this chapter. So understanding that that is what a mapping diagram is. We have our input, which is our X's, and our output, which is normally our Y's. They're putting an A there to represent area. So here they have, if we put an a 1 in place of X, what would our area be? Well, 2 times 1 would give us 2. So we're going to go ahead and put a 2 there. So notice we're going through and actually solving an equation. In this case, it's base times height, which is how we find the area of a rectangle. So now we're going to go ahead and put a 2 in place of X. So now if I put a 2 here, 2 times 2 is 4. So we'll put 4 in that box. Next, we'll put a 3 in there because that's the next one they wanted us to use. 2 times 3 is 6. And you can see the pattern. Now we'll go ahead and put a 4. 2 times 4 is 8. So there we're working with our inputs and our outputs. In a future lesson, we'll also learn about domain and range. Okay, so our inputs were 1, 2, 3, and 4. Those were what we inputted into our equation. And our outputs or our results were 2, 4, 6, and 8. Okay, so let's go ahead and work with another problem. Okay, B is working with perimeter, so I'll get you started on this one, and then you guys will finish it off. So for perimeter, well, the first input they want us to put in is a 1 in place of X, so we'll put a 1 there. So remember when you're doing perimeter, that is the whole distance around, so 2 plus 1 is 3, this would be another 2, so there's 5 plus another 1, so we end up with 6 for our perimeter. Okay, now they want us to go ahead and input in place of X a 2, so we'll put a 2 here. 2 plus 2 is 4, plus 2 plus 2 is another 4, which 4 plus 4 would give us 8. Okay, so you're going to go ahead and finish off letter B, and then you'll be able to check that off the answer key. All right, letter C is working circumference. So let's review really quick how we find the circumference of a circle. So once again, I'll get you started on this one, and then you'll finish it off. So our mapping diagram, they're telling us what they want us to put in place of what we would normally say was X. They are using R, which what does R represent here? That represents our radius, okay? And then they want us to find the circumference. So let's discuss how we find circumference of a circle. So there's 2 formulas that you use for a circle. We have pi r squared, and we have pi times diameter. So we have to remember which one of those is circumference. Well, I always remember that when I'm finding area always uses a little squared or a little 2 on our label. So this is the one that is our area. So we're going to end up using our bottom one for our circumference. So we're going to go ahead and use this formula. Okay, so if it's pi times diameter, well, our r is actually only half of our distance, and we need the full distance. Okay, so there's a couple different ways we could go through and do this. I personally am going to go ahead and just double my r. Now you could take pi times 2 times r, because you could do 2 times r would give us, and then we take that times pi, or you could go 2 times r times pi. It doesn't matter the order, but we know that we're actually doubling whatever it would normally be. Now I, on the other hand, am just going to go ahead and double that first. Okay, so if I substitute in pi times diameter, well, I have to figure the diameter. So if I have a 1 in here, well, what would my full diameter be? That would be 2. So I'm going to do 3.14 times 2. And give me just a second. I got to grab my calculator, which really I could do that one in my head. 3.14 times 2 is going to give me 6.28. Okay, so we're going to go ahead and plug in 6.28. Another way that that could actually be listed, because I know this box is pretty small, is sometimes at the advanced levels when you're working with that pi symbol, they will also write it like this. We actually took 2 times pi. So that's the way that my book does it, is it leaves it like this, 2 times pi. If you want to give the actual answer of 6.28, you could also do that. Okay, so let's go ahead and do another one. All right, so this time we're going to substitute in for our r a 2. So we're going to have a 2 here and a 2 there. So what is our diameter? Well, that's 4. 2 plus 2 is 4. And we have pi. So usually you could do pi times 4. They usually list the number first, so 4 pi. Okay, the actual answer to that, if we use 3.14 for pi, is 12.56. Okay, and as I said, you can pick either. If you want to leave it as just the 4 pi, that's fine. If you want to do it as 12.56, you could also do that. Okay, so we got you started on letter C. So now you're going to go ahead, you're going to go ahead and do the last 2 of letter C. And we're going to go ahead and move on to letter D. All right, letter D is working with volume. So once again, we have to go through and figure out, how do we find the volume of a figure? Well, to do volume of a rectangular prism, volume is length times width times height. And it does not matter the order in which you do those. So really, we're going to be doing 3 times 3, which is 9. So I'm already doing those 2 together, times the height. Okay, they've already gone through and given us what they want us to use for that length and width. So that part's not going to change in the whole equation. The only part that's going to change each time is just our h, which is our input. So this part will change each time. Okay, so they want us to put a 1 in first. So I'll put a 1 in place of this. 9 times 1 gives me 9. Okay, so now we'll go ahead and do the next one. So that 9 part, this part right here is still going to stay the same. Those are not changing. The only part that's going to change is the height in our figure. So we're going to do 9 times, this time they want us to plug in a 2. Okay, so we'll put a 2 in place of h. 9 times 2 is 18. Okay, so that's going through and working with substituting in. Our inputs in this case were 1, 2, 3, and 4. And our outputs so far, we have 9 and 18. So you guys will finish out the last part of this problem. So once again, inputs are going to be the numbers that you're inputting into the equation. It's that part that you're intentionally changing. And your output is the result that you get, or that output, that part that you get as a result of substituting in. Good luck with this activity.